Alright, in this problem, I went ahead and listed the knowns, which was the length of the barrel, and I converted that into meters. And then our starting velocity, our final velocity, and then we're trying to find the translational acceleration. Alright, so in order to do this, I selected this equation, and then derived it to here, and then I simply just plugged it into the numbers that we were given, and found the acceleration to be 8.8 times 10 to the 5 meters per second squared. The second part of the problem asked us to find the average rotational acceleration in radians per second squared. Alright, in this problem, it's kind of like a two-step thing, because we don't know the time. So in order to find the time, I used the average velocities formula, which is right here, and then derived into this, and then just plug in the numbers, and you get 0.001074 seconds. Alright, now that we have the time, we can go back and find rotational acceleration, which is down here, number 3. Alright, so I just list our known quantities here, and we are trying to solve for this. Alright, so you use this formula here in order to find it, and you derive it, and then you plug in the information here, and we get that it is 2.7 times 10 to the 7 radians per second squared. And lastly, the problem asked us to find the final angular velocity in rotations per second. So in order to do this one, it's just like any of the steps above. I had to go off to the side here, ran out of room. You list your givens and what you're trying to find. And once you do that, it becomes a lot easier to select the problem you need. The formula you need. So I selected this one because we only had one unknown here. And once you plug it in, it's 0 radians per second plus 2.7 times 10 to the 7 radians per second squared, which we found in step 3. And I ran out of room off to the side, so I just wrote t, but t was 0.001074 seconds. And then you get 29,000 radians per second, and since we're trying to find rotations, we just convert it to rotations, and it's 4,700 rotations per second.